In order to use the logical operators that we just discussed, first we must familiarize ourselves with the conditional statement, the if expression. The if expression adds flexibility to your code and makes parts of your code optional so that they can either execute or not execute based on your conditions. If the used condition returns a true result, the code will be executed. If it returns a false, the code in the body of the if will be skipped. Let's see a very simple example. Let's use the Pythagorean theorem about triangles. So we have three values, a equals to 3, b equals to 4, and c is equal to 0. And we want to calculate the c value. First we start with the keyword if. As you can see, it's in blue color. We haven't seen many blue colored keywords yet, but from now on we will see a lot of them. Then you have to give it a condition. We are not going to start with a condition, but we are simply going to say true. And on the next row, the body of your if statement starts. Calls that will be optionally executed. As you can see, we have a little minus here and a line that shows that we have currently only one row of body code. So if it's true, we want c to be equal to a squared of a squared plus b squared. This is the direct derivative from the Pythagorean theorem, and you must always end your if statements with the AND keyword. So, as you can see here, this is the body of our code, this right here. It's only one line. You can have as many lines as you want, but we're starting with a simple example. So if the condition here is true, only then this line of code will be executed. Since we don't have a condition, we simply gave it true, this line of code will now be executed. So let's see if that is really the case, and there we have it, c equals to 5. If I change this to false, like this, it's not going to be executed and our c value is still a 0 as we have defined it here. This is where we are going to give it a condition. Based on that condition, MATLAB will decide whether to execute this code or not. Now, since we never really use if conditions with a true or false purely in this pure form, instead we give them a relational operation as a condition or a logical expression, but we'll start with something simple. Let's say that we want to check if a is equal to 0, and if it's equal to 0, then we want to calculate it. So here we're going to say a equals to 0. So we are checking, we are saying if a is equal to 0, so this is a conditional statement. After it gets evaluated, you will get either a true or false. If you get a true from this expression, this piece of code will be executed. But we're going to change this piece of code a bit, since we want to have a equal to 0 and we want to calculate a. I'm going to change our formula a bit. And let's run it, and there we have it. We have calculated a. But now if I change a and it's no longer a 0, so if I give it a value, it's not going to be recalculated because this condition is now false. A is not equal to 0. Now, how about using the not operator to negate our result? We can use it to check if a is not equal to 0. So not equal to 0. We use the tilde and then the equals operator. This reads as not equal. So if a is not equal to 0, so any other value except 0 will give us a true result. Currently, a is not equal to 0 and this code will be executed. And since it's not equal to 0, it also has this value is also not correct. The a should be a 3. Now we will recalculate it and get our true. If we now change a to some other value, it's still going to be recalculated. But if we change it to 0, it's not going to be recalculated because now a is equal to 0 and we are checking if it's not equal to 0. Similarly, we can use any other relational operator that we have seen so far. So we can even use if a is less than or equal to 0. So if we give it a negative value, it's still going to be recalculated. If we give it a positive value, it's not going to be recalculated because now 5, when we compare 5 with 0, it's bigger than 0 and it's not equal to 0. So this expression is now going to give us a false result and this code will not be executed. We can use these conditions on more than just simple numbers. For example, we can use them to safeguard a concatenation operation. as you know, in order to concatenate two matrices, they both need to have the same amount of rows in order to concatenate them horizontally, or the same amount of columns to concatenate them vertically. So we can use an if statement to check their sizes before the concatenation. So we can say if the size of the first matrix, I have just copied them from a code that I prepared earlier so that I don't waste any time writing matrices in front of you, because you know how to create a matrix. And we want to compare the first size of the AV matrix against the first size of the BV matrix, like that. And if these sizes are equal, we want to concatenate these matrices horizontally. So AV, BV, like that. And finally AND. So let's run this, and we did not concatenate them. So as you can see, our AV matrix is still the same. Now, if we didn't have this if statement here, if I comment it out, we will get an error. And if you had some other code down here, your code execution would be interrupted, because now you have an error and you have no safeguards against this error. Now, if I put it back on, our matrices will not be concatenated, and we will not get an error. Now we can add a second if condition, and we can check if size of AV, the second size, is equal to the size of the second dimension of the second matrix. We want to concatenate them. Vertically. So AV, BV, like this. And AND, don't forget the AND keyword. Let's run it, and there we have it. Now, since the second dimension is of equal size for both matrices, we were able to concatenate them vertically. Now, if I change these matrices a bit, so if I say that now they have the same amount of rows and the same amount of columns, the first condition will be true and they will be concatenated horizontally. But once they were concatenated horizontally, the AV matrix was changed, and now we no longer have a true condition for the second a true result for the second condition. So you can even check your conditions just like that. Simply copy them, paste them in the command window, and you will get your results. Now, let's continue with a few other examples. Let's say that you want to check if a given number is even or odd. You will actually find yourselves in need to do this check more often than you think. So let's generate a random number. So number equals to round I, let's say between 1 and 100, and we simply want only one number. So for the size, we simply give it one row and one column. Next, we want to check if that number is even or odd. The way to do this is to use the rem function, which will divide a number by a given number and give you the remainder. That's why it's rems, short for remainder. So number divided by 2. If this number divided by 2 has a remainder of 0, this is an even number. So we're going to simply output this number, and let's run it. Let's suppress these outputs here. Let's run it. So we get the number 82. The number 82 is even, and we got it printed a second time. The next number 91 is not an even number, so it was not printed. And you can try as many times as you want. As you can see, when we get an odd number, we get the number printed only once. So we can also say else. This is the second part of the if statement. So the if statement can exist on its own, so you can have only if and execute this code only if that condition is true. And you can also have an else, which basically is your default case. So whenever the case for your if is false, the code in your else case will always be executed. The else is optional. So let's say that in the else, if the number is even, we want to multiply it by 2. So number equals to number times 2. Let's run it, and we have an even number, nothing happened. We get an even number, come on. Okay, there we have it. 85 is an odd number, and we got the 85 multiplied by 2.